Hello, welcome to the video on inscribed angles. This is our second example set B. And of course, I hope you had a chance to watch the lesson and the previous example set. I think the best way to learn with our system is just to kind of go through each example set in order. But let's go ahead and get right to it. So we're going to answer the following questions. And we're told that XZ is the diameter. Okay. So XZ is a diameter, and we also see that we have an inscribed angle. Okay, so this is an inscribed angle. And now, knowing that you have a diameter, okay, on a circle or going through a circle, okay, what does that do? What do we have right now? If you recall way back when we started studying circles, that a diameter is the widest part of a circle. So anytime you have a circle, that's a pretty bad circle, but here you have a diameter chopping through it, what you have is two semicircles. Okay, that diameter is kind of like that crossing line or that border that creates two semicircles. All right, so what we have is an inscribed angle in our figure here. We have an inscribed angle, okay, in a semicircle. And knowing that is really important because we have a theorem that states that an inscribed angle in a semicircle is a right angle. So this is a right angle here. Okay. So we're asked to find the radius of this particular circle. Okay. And to do that, I'm going to look at this situation, what I have here as, oops, I didn't want to do that, as a right triangle. Okay. Let me just kind of highlight that here for you. So you have this, this, and this. This is a right triangle. And what I'm looking for first is the hypotenuse, which is xz. And then when I get the hypotenuse, I'll divide it by 2, and that'll give me the radius, and that'll answer the question. All right, so let's go ahead and use the Pythagorean theorem to solve for the hypotenuse first. That'll be 12 squared plus 7 squared equals, I'm going to call this x for the time being, x squared. Again, x will represent the hypotenuse, xz. So this would be 144 plus 49 equals x squared, or 193 equals x squared. Okay, so to solve for x, I'm going to go ahead and take the square root of both sides, the square root of 193. Okay. Now, at this point in time, the square root of 193 is a diameter. All right, so this is equal to the diameter of this circle. So the question is asking for the radius. Now, I know some of you out there are saying, oh boy, I stopped here, I found the diameter and that was it. And that's kind of, that's kind of a common mistake, and that's something you want to remember going forward, that you always want to, reread that question before you leave it and say, okay, I'm done with the question, move on. Okay, you just solved for the diameter, but we need the radius. So therefore, we have to take our diameter, or the square root of 193, and divide it by 2. All right, so if you do that in your calculator, you'll get something around 6.94. So, okay. All right, so once again, this problem is not difficult once you know, or once you could apply these theorems that we learned. Okay, the whole key here was knowing that this particular angle, this inscribed angle, was a right angle. Okay, and that was a theorem that we learned from the lesson. All right, so let's take a look at our second problem. Okay, so here we have a quadrilateral, okay, four-sided figure, and each one of these angles is an inscribed angle. So we had a theorem that talked about the opposite angles. Okay, so what was that theorem? It said opposite angles are supplementary. So this angle here and this angle here are opposite angles. So if we add those two angles up, they're going to equal 180 degrees. So knowing that, I could simply go ahead and write an equation and saying, okay, I have an angle here, x plus 50. Okay, and if I add that to this other angle, 9x, these are opposite angles in this inscribed quadrilateral, I know I'm going to get 180 degrees. All right, so now I have a simple equation, and the question's asking to solve for x, find the value of x. So let's go ahead and do this. So this would be 10x plus 50 equals 180. And now I'm going to subtract 50 from both sides of the equation. And I'll get 10x is equal to 130. So now, dividing both sides of the equation by 10, I get x is equal to 13. All right, so hopefully pretty easy equation for you to solve out there. And once again, not a difficult problem if you know the theorem. Okay, here we have an inscribed quadrilateral, and we had a theorem that said the opposite angles are supplementary. And of course, we have to take that theorem and translate it into an equation. Okay, all right. So, like I said, if you're struggling, and you've heard me say this time and time again, do not get frustrated. Okay, if you're saying, "Oh boy, I got this wrong," just go back, take your time with things. Make good notes and work on it. Okay, but I'll tell you one thing for sure. If you're having problems solving equations, for example, it's just not going to get any better. You're going to continue to have problems. So go back and do what you need to review on. Okay, and of course, if you're forgetting these theorems, you should be having your notes with you as you go through these problems. It's just too much to memorize from the lesson. Taking a test is one thing, but when you're doing practice problems, you should have your notes with you. All right, let's go ahead and take a look at our last problem. Okay, I believe this is our last problem. Yep. Okay, this is our last problem. So here we want to go ahead and find the value of x and y. So we have two inscribed angles that intercept the same arc. So once again, we had a theorem that says that two inscribed angles that intercept the same arc are equal. So I know that y and x, okay, or y and 8x, these two inscribed angles are equal. Okay, so now to find the value of x and y, I need to kind of figure out how to write an equation out of this situation. So I'm going to focus on this part right here. Okay, so I have an arc. Okay, the arc is the measure of this arc is 12x plus 68. Okay, that's this intercepted arc right here. And going back to that theorem that we learned in the lesson, saying that the measure of an inscribed angle is half the measure of its intercepted arc. So I'm going to just focus on this particular angle right here because it has x in it, okay? And this has x in it, so I can write an equation that has just the variable x. So 8x, okay, that inscribed angle is half the measure of the intercepted arc, 12x plus 68. All right. So at this point in time, if you haven't tried to solve this equation, now's a good time to see if you can solve it. So what I'm going to do here is multiply both sides of the equation by 2, okay, just to get rid of this 1/2, and I'll get 16x equals 12x plus 68. All right, so now when I move 12x from both sides of the equation, I get 4x equals, and I'm going to actually do that. I don't want to take too many shortcuts. So I subtract 12x from both sides of the equation. I get 4x equals 68. And now when I divide both sides of the equation by 4, I am going to solve for x. So x is equal to 17. All right, but am I done yet? Okay, you said, okay, great, we solved the equation. No, let's go back and answer the question, okay? It says find the value of x and y. So x is equal to 17, but y is going to be the same as this measure of this entire angle, which is 8x, okay? So y is going to be equal to 8x, all right? Why? Because these represent the same, these represent two inscribed angles that intercept the same arc. So now I know that x is equal to 17. Okay, so if x is equal to 17, y is going to be equal to 8 times 17, or y is going to be equal to 136. Okay, so once again, not difficult. Okay, if you're paying attention and you're taking your time and you have these basic equation solving skills and you've watched the lesson, these aren't too tough, hopefully, for you. But once again, the whole idea here is learning. Okay, so if you learned something, if you improved, go back and try these problems later on. All right? Okay, so keep working hard. We'll see you soon.